Welcome back to speed, distance, time, because we didn't quite finish. So I'm doing a little bit more for you and then we'll go into the higher tier. So we looked at this equation here, speed equals distance over time. And there's a nice little triangle you can remember, and that's the D at the top because the D is the first letter in distance, then the S and then the T at the bottom. And we went through these two equations. A snail walking 50 metres in 10 seconds. So 10 metres goes at the top, 10 seconds goes at the bottom. So it's 50 divided by 10 equals 5 metres per second. A very speedy snail at that. And then we said about the dog on wheels. And we've got speed here, that's that one. And we've got time there, so it's that one. So you times them together and you come up with 200 metres. They normally give you most equations, but this is the one that they probably won't. So if you can remember this one, then that would be fabulous. Now for the higher tier, you need to be able to do this bit here. You need to go back to the graph and use this equation to work out the speed of the dog. It says, how fast was a frog-dressed dog? That's this one here, for those of you who didn't watch the last one. Frog-dressed dog. How fast was it going in its first and third part of the journey? Now it's talking about this graph. It's asking you to work out the gradient of the lines. This is higher tier. It's okay though. So the first bit of the graph is this section here, and we use it. They ask you to show your workings, draw some lines on the good old graph like this. So that is covering this section here, this first part. And we look at it and we say, okay, this dog has travelled in 100 seconds. It's travelled 450 metres. Okay, because I'm just reading it off the graph. So if I look back at my equation, dst, I've got the distance and I've got the time. So I put the distance divided by the time. So I would come up with distance, 450 metres divided by the time taken, and that would equal 4.5 metres per second. Don't forget that unit, really, really important, and don't forget a calculator in the exam because you will need it. Even for the simplest equations, I kid you not. You always check. Now in this one, this is the third section of the journey, and again you're working out the gradient of the line. A little bit more tricky in this case, so let's draw it on there. And you're looking at the time. Now it's not the time here all the way back to there, it's this time here. So here, looking at my scale, which is a really bad scale, I must say, I found out earlier, this is about 212 seconds. Reading it off here. And this one is about 150 seconds here. 150 seconds. Not the easiest of numbers. Thank you very much. Right. Now, what is the time between those two figures? So it's quite simple. You're going to do 212, take away 150. And we come up with 62. So the time taken here is 62. Let's put that in. 62 seconds. Now, how far has it gone in these 62 seconds? Well, it's gone from 450 at the bottom, 450 metres, and it's then at 550 metres at the end. 550 metres. So the total distance it's travelled is 100 metres, because I want to take away the other 100 metres. Shove it in that lovely old equation here, dst, distance divided by the time. There's the distance divided by the time. So it's 100 divided by 62 seconds. And that will give you the speed, oh my goodness, it's gone mad. That will give you the speed of the dog dressed as a frog in that last stage. Now, as I say, I'm going to use a calculator just because. Okay, and it comes out at 1.61, round it up to 2 decimal places, meters per second. That's higher tier. Okay, fab.